that structure that's going to get formed. Those astrocytes, those cells, they're reaching out and they have very tight junctions, and what it does is it ensures that anything from the blood, or it's trying to make sure that anything from the blood cannot enter those capillaries. It is a way that we do stop a lot of these harmful substances, but it's allowing necessary ones to cross. For example, the oxygen and the glucose. We form in this barrier system. We form a barrier at the point of the blood and the CSF, because we have the two entries, and one of the entries is at the point of those ventricles where we make the CSF. So we have the tight junctions for those ependymal cells, those neuroglia. For the blood-brain or the barrier system, here's what we have that can move, that can make its way to the tissue. It's very permeable to water, which is good, glucose, which is good, but then also lipid-soluble substances, meaning anything that can dissolve in fatty material. Uh-oh. What is the plasma membrane of a cell? Fatty material. So therefore, if it dissolves in lipids, it can cross. So if you look at substances like alcohol, this is the reason that when you consume alcohol, it gives you what they term the buzz, because that chemical is crossing this barrier before the liver can detoxify it. So it affects those nerve cells to give you what they call the buzz. Nicotine crosses. If you smoke or know anyone who smokes, a lot of times that nicotine, it gives them that feeling that they get, and in some cases, like say people who do smoke, if they haven't had a cigarette for quite a while and they do go smoke one, they might get dizzy, okay, because they haven't had that chemical cross. So the sensation is almost new again. Anesthetics cross. This is why anesthesia works. It's been made to cross these lipid barriers. It is a little permeable to sodium, potassium, chloride, urea, creatinine. But that is because the brain is going to work to maintain its pH. And it's going to have the ability to control substances that could affect the pH of the tissue. Even though this barrier system is so important, it's also the reason that brain infections, any type of like mental disorders, like people who might have depression, that sort of thing, it's the reason that it has been so difficult to get medications to work. Because the medications, like early on, early 1900s, mid-1900s, when they were developing medications, say for example, to treat stuff like depression, schizophrenia, all these different types of, disorders that we were learning about, the medications seemed ineffective. But that's because they had to be developed so that they could dissolve and cross in through or through these lipids. So anything that we use to treat the brain, they have to engineer that medication to cross this barrier system. Antibiotics, I think they have one that might work. I'm not exactly, don't quote me on that. My mom got diagnosed, it's probably been 5 years now. She and my aunt both, it happened almost at the same time. Both of them ended up with a terrible brain infection. Unfortunately for my mom, it was around the area of the brainstem. My aunt, it was in the area of the cerebrum. And so my mom actually ended up at UVA. She was in UVA for a little over 6 months. And my aunt ended up at like Lynchburg Hospital. She was there 2 or 3 months, I can't remember. But they were able to like go in and actually sample that brain tissue to try to identify bacteria that had invaded. And they never were able to identify the bacteria. But the 2 hospitals stayed in contact because both my aunt and my mom live in the same town where I grew up. And so they didn't know if like, oh, are we looking at some kind of issue that's popping up, blah, blah, blah. But it wasn't. But they finally landed on a regimen of medication, and it wasn't an antibiotic, but it was an antibiotic that they had to put in through a port. They had to like put in a port and had to put it in that way. And they were both on it for 6, 8 months. I mean, it was like this huge time frame. Now, because of where my mom's infection was at the area of the brainstem, she's got lasting effects. Okay, like her ability to, like she's now legally blind. She has lots of other health issues because of it. Now, my aunt, because it was in the area of the cerebrum, she doesn't have any effects. Okay, but they never were able to identify what the bacteria was. They just got lucky in the medication, really, is what happened. So, you know, it's very difficult to treat any type of infection in the brain because of being able to get the medicine across the barrier system. So even though extremely important, in times where something does end up infecting the brain, it can be very difficult to treat it. Other medications that have been created for treating like depression symptoms and that sort of thing, those medications have come a long way. And a lot of them are extremely effective because they've learned how to get them to cross the barrier system. So now, as we continue to look at these parts of the brain, we're now going to look at what's called the hindbrain and the midbrain. So we're going to kind of be looking at areas rostral to caudal. So as we begin to look, we're going to kind of move in this direction, looking at all these different parts of the brain. So as we begin to look, medulla oblongata. You gotta love that term. And I can't say that term without thinking about waterboarding. Okay? So, you know, medulla oblongata begins at the area of our foramen magnum and is going to end at the pons. So, when we look at this area of the brain, we're going to find the fibers, axons, okay? We're going to see that in this part, the medulla oblongata, fibers are connecting the brain to my spinal cord. Do you guys remember ascending descending. All right, so now ascending, fibers going up, okay? Do you guys remember first order, second order, third order? Okay, we're now looking at how some of that information is going to pass. Descending fibers. What happened to information as it moved up the spinal cord? Do you happen to remember what area of the brain information went to?
The thalamus.
The thalamus. That's trying to get represented, and somebody drew on this half of the brain, but it kind of looks like a little projection and an area around it and that sort of thing. That would be the idea of letting us know where the thalamus is. All right? So if you remember, it was the job of the thalamus to take that information and send it to the area of the brain it needed to go. And a lot of that information went to areas of the brain, and now that we know there is a cerebral cortex, okay, that's where a lot of the information gets to go. So, as information passes and it gets integrated and we get a response, we got to have descending information, right? So, descending fibers, for a lot of the times, okay, I never say all in science, okay, for a lot of the times, that means that this area is processing a lot of that information, and it now has to send the information back down so it can get to the area of the body it needs to go.
It goes through medulla. This is the point?
That's the point we find those fibers, that we can find those axons that will allow it to have that connection to the spinal cord, so that at that spinal cord it can leave the area that it needs to leave and carry out the response. So now we've learned that we have this cortex, and this cortex that exists, okay, plays a huge role in what happens with our skeletal movement. Purposeful movement. When we begin to think about other types of movement, it might actually be affected by another part of the brain, okay? But a lot of what we do consciously, pick it up, set it down, move it, write it, whatever we do consciously, a lot of that is going to be because of this cerebral cortex. Okay? So, we're going to see that we have neural networks. We're dealing with both sensory information coming in, motor information going out. Sensory, we've mentioned before. This is all of this information out here that's coming in. Hearing, equilibrium, touch, pressure, temperature, taste, pain, all these sensations, okay, that are coming in. Motor is just like the term implies. Anything that we get movement for with these muscles. All right? Chewing, salivation, swallowing, gagging, vomiting, respiration, speech, coughing, sneezing, sweating, okay? So we got all this sensory information. It's going to get to go in. We're going to get to process it. We're going to get to have responses come out. And those responses, I mean, do you think about every single